Good day to you all. You are welcome to our class, EPO Mathematics Lab. We've been talking about how to prove theorems in circle geometry. All those theorems, if you miss it, how to prove it, then go and watch the videos. Today, we want to solve a problem on the circle geometry. And the problem is, in the diagram below, this diagram, points P, Q, R, and S are on the circumference of a circle. They are on the circumference of a circle. I've explained the circumference of a circle. Center 0, okay, with this center. If PO is parallel to QS, PO, that is this, is parallel to QS. Okay, this line and this line, they are parallel to each other. OQS, angle OQS is 35 degrees, and the angle QOS is 110 degree, 110 degree. Find the angles denoted by letter X, Y, and Z. It's a WAEC question. And now I'm going to solve this problem. By solving this problem, we have to look at the diagram very well. That's the reason why we have to know the theorems. If you have the theorems in your memory, then you'll be able to apply it. The theorems is very, very germane and it's very, very important. You need to know it so that you'll be able to apply it. Now I can see something here. If this 110, then I can find my y by saying, if I look for the exterior angle of QOS, such that I can say reflex QOX is equals to 360 minus 110 degree. Yes, the reason is what? Angle at the center. Angle at the center of the circle. Or let me say angle at a point. Angle at a point. Angle at a point is equals to what? 360 degrees. So that our QOS equals to what? That will be 250 degrees. So what I'm saying is that from here to here is what? 250 degrees. From here I can determine the value of y. Because I'm having 250 at the center, then y at the what? At the circumference. And I can say QOS is equals to 2 times y. Reason, angle at the center is twice the circumference. Is twice the circumference. Angle at the center is twice the circumference. Now I can see what? 250 degree equals to 2y. We divide both sides by 2. Then y is equals to what? 125 degree. Meaning that the value of our y here is what? 125 degree. 125 degree. We've done the value of y. Now what else can we find? Can we find the value of x? Yes. The value of x, we have a chord here that produces. Okay, I can see something. Then I have a chord PQ that is producing angle to the center. At the same time, it's producing angle to what? Circumference. Angle at this point is twice this point. But here I can find the value of x. Oh, how can I find? Okay, I can find this place. Because this QS and OPO, they are parallel to each other, and we have a line in between them, known as transversal line, then this is equal to this alternate angle. So you can say SQO is equals to POQ, which is equals to what? 35 degrees. Reason, alternate angle. We can only have alternate angle when you have two parallel lines and we have a transversal in between them. So this and this are alternate. Now I determine the angle at the center, and I can determine this. I can determine PSQ. So that I can say my POQ is equals to 2 times PSQ. 2 times PSQ. So POQ, which is 35 degree, equals to 2 PSQ. We divide both sides by 2. By dividing both sides by 2, then PSQ equals to 17.5 degree. So what I'm saying like this is 17.5. 17.5 degree. Then I can determine the value of s in the triangle. Let me just say in triangle PQOS 180 minus 110 plus 35 plus 17.5 degree. Reason, sum of angle in what? In the triangle. So I can say our s equals to 180 minus, this is what? 145. That will be 162.5 degree. Alright, and that will give us what? 17.5 degrees. So our S is also what? 17.5 degrees. So that means this place is also what? 17.5 degrees. Now we are looking for the value of Z. We've already determined this place to be what? 35 degrees. So I can find Z. How can I find Z like that? By saying in this triangle QOP. Q in triangle QOP. Then I can find QPO because this is a radius, this is another radius. So this isosceles triangle QOP is an isosceles triangle. So I can find the base. So I can say QPO is equals to 180 degree. Okay, no. I can just say, okay, like I say in the triangle base, I can just say I can just say Z. Okay, if this is X degree, and if this is X, this is also 17.5. Base angle of an isosceles triangle. Base angle of what? Of an isosceles triangle. That is the triangle BOS is an isosceles triangle. So our what? OPS is also equal to what? 17.5 degree. 17.5 degree. So we can determine what? We can determine Z now. How are we going to determine Z? If you look at the diagram very well, you see that our Q0P. So I can say in triangle Q0P, then we can say our Z plus 17.5 is equals to 180 minus 35 degree over 2. Base angle of an isosceles triangle. And that will give us what? 180 minus 35 will give us what? That is a 165. If I'm not mistaken, that's a 50. That will be 145. Yes, 145 over 2. And that will give us what? 75.2 in 17 is what? 7. 2 in 5. That is 70 what? 2 in 14 is 7. 2 in 5 is 2. 72.5. So that was 6Z plus 17.5 equals to 72.5. So Z equals to what? 72.5 minus 17.5. Z equals to what? 55 degree. So that means our Z is equal to 55 degree. Z equals to what? 55 degree. Now we determine the value of 125 degree. We determine the value of X to be what? 17.5 degree. And we determine the value of Z to be what? 55 degree. So the next time that we're going to meet, we are going to solve another example of what? Circle geometry. Thank you.